Hey guys, this is the second example for lesson 1.1. And in this example, you're going to see that we have the sum of two absolute values is equal to a constant 10. And it's a little bit more complicated than it was in the first example when we just had an absolute value equal to an absolute value. So the key concept that you're always trying to do when solving an absolute value equation is to isolate just one absolute value. Okay, get everything else to the other side. So in this case, I'm going to choose to isolate x plus 3 just because it's on the left, and it doesn't really matter, but we're going to end up with the absolute value of x plus 3 is equal to 10 minus the absolute value of x plus 5. So once we do that, we are ready to split this into two equations, okay, a positive and a negative. So when we do that, I'm going to go ahead and call this one equation 1 because this problem is a little bit more intricate than the first one. And it's going to be a little bit easier to follow if we give this first two a number. So equation 1, we're going to take the positive version. So once this absolute value on the left here is isolated, when we set these two equations up, we drop those absolute value bars. So it's just x plus 3 is equal to the positive version of the right, and I actually have to keep the absolute value bars around the x plus 5 here because it's not just an absolute value equal to an absolute value. There's this 10 here, and this 10 throws this into a whole nother category, okay? So we just have to be patient when unwrapping this one. So that's the first equation. The second equation, which would be the negative version, is going to be x plus 3 is equal to negative 10 minus the absolute value of x plus 5. Okay, now I'm going to go ahead and rewrite this second one right away because this is a really important tool that you guys can use whenever you are taking the negative of subtraction. Okay, so two quantities being subtracted. What you can actually do to distribute that negative out front is just reverse the order of subtraction. Okay, and before we kind of jump in and just start solving, I want to slow down for a second and show you what that looks like in a really simple example. Take, for instance, 5 minus 3. You have 2. We'll reverse the order. 3 minus 5 is negative 2. And that's exactly what we do when we set these two absolute value equations up. We want one side to be positive, and we want one side to be negative. Okay, so by reversing that order, that's exactly what you're doing, is you're making that right side negative. So let's get back to it. Okay, so on this equation on the left, equation 1, we are ready to solve it. And if you notice, I still have an absolute value here. So the step 1 of solving an absolute value equation is isolate that absolute value. So I'm going to we're going to move it over here because there's a negative sign in front of it. So if I move it to the left of that equal sign, it will become positive. And if I move all of these terms that are on the left to the right, then they will just take the negative of them. So if I move x over, I will have negative x, and if I subtract 3 from 10, I will end up with 7. All right, so we've isolated our absolute value. We are ready to split this into two equations. So we're dividing this one into two equations. So I'm going to switch my color here real quick so it's a little bit easier to follow. So the first equation is we drop the absolute value and we set it equal to the positive or the original version on the right side, which is negative x plus 7. So we keep everything the same. Or x plus 5 is equal to the negative of that right side. Okay, so let's solve each of these, see what we get. So if I add this negative x, so you're doing the opposite, right? So get your x's to one side. You would result in 2x. If you subtract 5 from both sides, you end up with 2. So x is equal to 1. Or, let's solve this one, see what we get. X plus 5 is equal to, distribute your negative, which would be x minus 7. Look what happens here. If I subtract x from both sides, I get 0, and if I move the 5 over, I get negative 12. Well, 0 does not equal negative 12, so I don't get an answer there. this x equals 1 is the only solution I gain from that piece, okay? So let's come back over here now to equation 2, and let's do the exact same thing, okay? Let's isolate our absolute value that we have left. And in this case, it's already positive, so I'm going to move the 10 over to the other side. So I'm going to keep that absolute value right there. And don't freak out that it's on the right for right now. Just kind of keep it where it is, and we can move it around in a minute. And this is x plus 13. Okay, so since it's a little bit more appeasing to our eye, if the absolute value is on the left, just switch it around. And now we're ready to break this into two equations. So let me grab a different color. Okay, so first equation, since we've isolated our absolute value, we drop the absolute value. So it's x plus 5 is equal to the positive of that right side, or the original of the right side, or x plus 5 is equal to the negative of that right side. So let's solve this. Whoops, I don't have to write that again. If you get your x's together, look what happens here. You get 0 is equal to 8. 0 doesn't equal 8, so that doesn't give us an answer. So come back over here to this one, distribute your negative, get your x's together. You get negative 18 divided by 2, x is equal to negative 9. So you get an answer from each one of our original splits, right? But we also have these like really weird things that happen here, and that's okay. And I want you guys to see that in these examples. In the event that it happens in your homework, don't freak out, okay? So absolute values, when we drop those absolute value bars, we're changing the equation, which oftentimes results in these kind of weird circumstances. And in Algebra 2, you heard a lot about extraneous solutions and all of that. So just to be safe, it's always a good practice to plug your solutions back in just to verify that they work and that your equation in this case will equal 10. And that's it.